Hi there, this is Dhiru Munduluru. Now I would like to spend few more minutes to ensure that we really have a firm understanding on how object references behave when they are reassigned with other object references or with entirely new objects. This is related to pass-by value mechanism, which we discussed earlier. We know that in Java, data is passed to methods via pass-by value mechanism. And we also said that it would be the same with assignment statements. But with assignment statements, we may get into situations where the same object reference is reassigned multiple times with different object references. And we need to be clear on what is happening with that object reference. So I think it would be good if we spend few more minutes on this particular topic, as it is really fundamental and there's no point moving ahead without a firm grasp of this. So let's just go ahead and use the same student example and extend it a bit for this particular demo. So here is the student test class which we have seen earlier. So we are creating three student objects, student 1, student 2 and student 3. Let's not worry about student 3 here. Okay, let's just consider student 1 and student 2. And in the interest of time, I have already created the code for this demo. So let's go ahead and look at each of the statements here one at a time. I'm going to uncomment it and we can test it. So let's just consider only student 1 and student 2. Student 1 was John. Initially it is Joanne and later it was corrected with John, and student 2 is Raj. And let's not worry about the third student. And here we have the fourth student here. So let me uncomment it and let me comment from here. So to student 4 we are assigning student 1. Okay, and student 1 basically is referencing this particular student object called John, right? So student 1 basically is not student object itself, but student 1 has the memory address of this particular student object John, right? We know that. And when we do this kind of an assignment, we know that a copy of that memory address which student 1 is holding will be made and it will be assigned to student 4, which means that both student 1 and student 4 have the same memory addresses, okay, and that memory address would be referencing this particular student object. And here we are printing the name of student 4, and obviously it has to print John, and we know that. So let's go ahead and compile and run this. So let me compile it, let me run it, and as you can see the last statement is name of student 4 and it is printing John. Okay, so student 4 and student 1 are referencing the same object, and let's look at the next set of statements. And here we are invoking the update profile method using student 4, and we are updating the name to Mike, and we are printing the name of the student via student 1. Okay, so when we do this, we know that it has to print Mike because student 1 and student 4 are referencing the same object. It's just that the name is updated via student 4, but if we try to access the name field via student 1, then it would still give us the updated name. So once again, let me compile it and let me run it. So once again, as you can see, for the student 1, it is Mike, and for student 4, it would also be Mike. Okay, so that's one thing. So let's scroll down, and here we are assigning student 2 to student 4. Okay, so what is happening here? Student 2 is referencing another object where the name is Raj, right? So student 2 is holding the memory address that references student object Raj, and that memory address, when we do this kind of an assignment, now we know that a copy of that memory address is made and it is assigned to student 4. Okay, so student 4 earlier it was having the memory address of student 1 of the object that is being referenced by student 1. So that is now overwritten with a new copy with a new memory address, and that memory address is pointing to the object Raj. Okay, so name of student 4, which was earlier Mike, now it will be Raj. Okay, as you can see, it is Raj. Now, so student 4 has been reassigned. Now let's say we are reassigning student 2 with student 1. Okay, So a memory address, a copy of the memory address that student 1 holds will be made and will be assigned to student 2. Okay, so that's how pass by value mechanism also works. So student 2 will now reference the object Mike, right? But don't assume that student 4 will also do that, just because in the earlier statement student 2 is assigned to student 4. Okay, so just don't think that just because student 2 is reassigned here, that would also impact the student 4. So that's not going to happen. It's just that at this instance of time, it's where student 4 is reassigned with student 2. So a copy of student 2's value, which is the memory address, is assigned to student 4, and both of them have the same value at this point. But student 2 is just updated with the student 1. So a copy of the value that student 1 holds, that memory address, is going to be assigned to student 2, but student 4 will still hold the value which was assigned here by this assignment statement. Okay, so student 4 would still point to whatever student 2 was pointing to at this point, which would be Raj, but student 2, when we invoke the name via student 2, it will be Mike, right? Because we updated here. So let's go ahead and recompile and run it. Okay, so student 4 is still pointing to Raj and student 2 is updated to Mike. Okay, so just the main thing I'm trying to demonstrate here is that just because we reassigned this, it doesn't mean that student 4 will also be updated and it would point to this particular object, student 1's object. So that's not going to happen, because everything is like it works with like pass by value. A copy is made here. Okay, so that's with that. So student 4 is still going to reference Raj. Okay, and it's not going to be updated. So here, instead of reassigning with an object reference, we are assigning a new student object, a brand new student object. And let's compile and run this. Now it is giving an error here, a compilation error. It says no suitable constructor found for student. And that's because here student has 2 constructors. Okay, so there is no args constructor here. And we know that if there is a constructor in the class, the compiler is not going to insert a no args constructor, right? We know that. So there is no args constructor. We either have to manually insert one or we will get the compiler error. So let's not do that and let's invoke one of the constructors. So let's just say Alex. Okay. And let's also go ahead and print all of these here. Now the compiler error is gone and we are printing student 4, which is now referencing Alex, and student 2 and student 1 are referencing Mike. Okay, those are the last 2 statements here. So now the question is, what happened to the object Raj, right? Because there is a reassignment here, and what happened to the student Raj? So the object corresponding to Raj is still there on the heap, but it is just that it doesn't serve any purpose. And that's because it does not have any references. So it is orphaned now and it is considered as abandoned. Okay, but it is still occupying space in the memory. And this is where Java's wonderful garbage collector comes into play, and it would soon reclaim the memory that is occupied by Raj's object. Okay, because it doesn't have any more references, the garbage collector will reclaim the memory that is occupied by that particular object. And that's Java's automatic memory management. Okay, and it simplifies a lot of things. And we will study garbage collection in detail in JVM internals chapter. So that's about it. And I hope you are now very clear about how object references work when they are reassigned with other object references. Only copy of memory addresses are made when they are reassigned, which is what is also happening when object references are passed to methods, right? That is passed by value. If it is still not clear, just implement this program and play with it a bit and it should get clear. Thank you.